Good morning, everyone. This lecture I'm going to record for Term 7 students of Process Engineering at Memorial University. So in our Friday's lecture, we work on cascaded split range control simulation, how we design this in Hysys. Before I jump into the Hysys, I just want to explain you some points. So when I say cascaded, that means one controller dictates another controller what to do. And in the split range, it has one process variable and more than one manipulated variable. So one transmitter control two final control elements, which are called valves, which range from 0 to 100%, and split them into 0 to 50% for one valve and 50 to 100% for another. So if I explain you this split range controller here, as you can see, this is our system here where we have the cold water coming in and we have the hot water coming in. Both of these waters are getting mixed, and outlet of the mixer we will have a temperature which is the mixture of cold and the hot water. So in the split range control, we are providing the set point to cold water and hot water so that we can have the desired temperature at the outlet. You need to read further chapter 14 and chapter 22 from Marlin book on process control and designing. I will post this book on D12 so you don't have to find it in the library. Now let's work on Hysys and see how we simulate this system in Hysys for cascaded split range control system. So it is saying that cold and hot water streams are being mixed in a mixer. Cold water is at 23 degrees Celsius and hot water has a temperature of 82 degrees Celsius. Each stream has a flow rate of 192 kg per hour and at a pressure of 350 kilopascal. Consider a 10 kilopascal pressure drop across each valve. This is the thing which we definitely need in dynamic simulation, because in the dynamic simulation we design our system based on the pressure drop on each equipment. Develop a data logger strip chart for SRG, which is your split range controller. Temperature at the exit of the mixer. So we are looking to set up our outlet temperature over here, and the setup and the set point for flow controllers 1 and flow controller number 2. So flow controller number 1 is associated with cold water and controller number 2 is associated with hot water. Use ASME steam as fluid package. In SRG, in the split range controllers, use 0 to 50% for controller 1. Let me highlight this statement, and 50 to 100% for controller number 2. So by that it meant to say, if we have the output of this controller within the range of 0 to 50%, controller 1 will operate while the controller 2 will be in idle state. In terms of output being 50 to 100% over here, controller 2 will operate and controller 1 will be in idle condition. Idle means this valve will be closed at that time and this valve will open, depending upon what is the temperature at the outlet. If let's say our set point is 50 degrees Celsius, then and our process variable temperature is at 48 degrees Celsius, let's say, so we need to increase the temperature. In that case, this split range controller will close this cold valve and it will open this hot valve a little bit so that the temperature can reach to 50 degrees Celsius. We will do some simulation analysis in Hysys about this in this tutorial. So these are some specification of our controllers, controller number 1, controller number 2 and split range controller. So let's move to the Hysys. The first step is we need to provide our components. We have the water here and the fluid package we are using is ASME. So let's move to the Hysys and see how we simulate this cascaded split range control system in Hysys. So the first thing is we need to add our component and the fluid package. From our workbook, our component is the water and fluid package is ASME steam. So here we are going to add water in our system, and my fluid package is ASME. If you have the water in your system, I strongly encourage you to use ASME steam, especially for your upcoming assignments, because this fluid package has steam properties in it. So let's go to the simulation here, and let me hide this. I don't encourage you, or I don't suggest you to close the messages, because if there is any troubleshooting in the Hysys, you definitely need to see here. And let's click this and auto hide. Now we have some more space here. So the first system, the dynamic simulation, is we need to develop this as a steady state system. As you can see, I have one mixer and 3 valves. So let's go here. I have this mixture, bring that into your solver, and 3 valves here. 1, 2, and 3. So let's start with this one, and I give it a name of valve number 1. For this inlet, I have the cool water, and the second one is the hot water here. So I give it a name of cooled water, and let's say the stream output is number 1. And if you recall, when I read this workbook, we need to consider a 10 kilopascal pressure drop. So when I read this workbook, it says that consider a 10 kilopascal pressure drop across each valve. So let's come here and go to the parameters, and here we can type in 10. Similarly, we will define our valve number 2. And this one is for hot water inlet. And the drop-in pressure is the same for each valve. So we have 10 kilopascal drop-in pressure, and now we can close this. The next equipment our in line is the mixer. So we are going to mix steam number 1, and we are going to mix steam number 2. And let's say my outlet is number 3. And now you can close this. Now this is our last valve, the valve number 3, let's say. And its inlet will be number 3, whereas the outlet will be hot and cold water. And similar to the rest of the valves, the pressure drop given is 10 kilopascal. So for now we have developed our basic system in Hysys, but it is not simulated, of course. Now let's provide the properties here. So it is saying that for the cold water, the temperature is 23 degrees Celsius. And each stream has a flow of 192 kilogram per hour and a pressure of 350 kilopascal. So let's provide this information to our cold water stream. We double click this, and the temperature is 23 degrees Celsius. The pressure is 350 kilopascal, and my mass flow rate is 192 kilogram per hour. The next is you need to provide the composition here. Because it's only one component, just enter 1 and press OK. As you can see, I have defined my stream and it has converged. Now let's do the same thing for hot water stream. In the hot water stream, according to our workbook, the temperature is 82 degrees centigrade, and mass flow rate and pressure remain the same. So let's go here, and my pressure is 82. My temperature is 82 degrees Celsius. My pressure is 350 kilopascal, and my mass flow rate is 192. Let's come to the composition. It's only one component, so you just enter 1 here and press OK. Now my stream has been defined. As you can see that after defining my both streams, all the system has been converged, and now we can move to the dynamic simulation and the steps for the controller setup. However, before that, we just need to size our valves. By that I meant to say, let's click on valve number 1. If you recall from our previous lectures, we did have the values of the CV that we used to provide into our valve. However, in this question statement, we don't have the CV value. So what we will do, we will ask Hysys to work this for us. Now Hysys has identified a value of 1.406 US gallon per minute for this valve, and you just need to click size valve in order to tell Hysys that you are okay with this value. Now I can close it. Same procedure for my valve number 2. You go to the rating, and this is the value. If you have your own value for designing, you can input this here. For now I'm taking Hysys value. You just confirm Hysys that this is okay, and the same step for our rating here. If we go to our system here, we have two PID controllers and one is a split range controller. So you go to the dynamics and control. This is my PID controller. Bring one controller for valve number 1 and second controller for valve number 2, and this is my split range controller, and we bring it over here. Now I can close my model palette because I don't need anything further. Let's reduce this size so we can see it in a good way. So let's start with the first controller. You need to double click on this controller, and here it is asking us what is the process variable that we want to control. So we want to control basically the mass flow rate of stream number 1. So this will be my select, click on select PV. This is my stream number 1. As you can see, it is stream number 1, and let's look for mass flow. Now as you can see that Hysys has developed a transmission link between my controller and stream number 1. Now how we are going to manipulate or make adjustment in this flow, mass flow of stream number 1, that is by manipulating valve number 1 here. So that is what is your output object. Click on, select on output object, and these are all the output object in our so far simulation. My concern is valve number 1 here. Click on valve number 1, click on actuator desired position and hit select here. As you can see that Hysys has developed a link between the controller and valve number 1 when I provided the output target here. So the way you can make it a little bit better, just click on this, go to the flow sheet and modify. This will be activated. Just click on this one, flip horizontal. If you unselect this, you will not be able to have these options available. You need to select the object if you want to use these objects here. So far we have defined our process variable for this controller. We have defined our output, and the next is it is asking us what is the range for your PV. Now go to the parameters here, and this is the place where we need to provide the range, but I just want to mention something here. So as you can see that this is my reverse action controller, and it is true because if there is any increase in mass flow rate in stream number 1, then we can close our valve number 1 in order to control this flow rate. So this is why it is called as a reverse action controller at the moment. Now let's go to our workbook and see what is the range for controller number 1. So here it is, my controller number 1, all properties in this table. So the range is 0 to 350 kilogram per hour. So I click here and it is 0 to 350 kilogram per hour. And the tuning parameters for this controller are The gain value is 0.5 and the TI, which is the initial time for calculation, is 0.45. So this one is 0.5 and my TI value is 0.45. And then before you are closing this, just click on the faceplate. This faceplate is something that we will use when we run the dynamic simulation. One thing you must notice here, that at the moment the set point is 192 kilogram per hour, but we can always change it using our faceplate or the detailed window of FIC 100, which is this one. So let me close this and then go to the second controller here. Again, we want to control the mass flow rate in stream number 2. So you click on select PV, your process variable, and this is my stream number 2. You can type in or you can find out from the list. So we need to know the mass flow. So click on the mass flow and click on select here. As you can see, Hysys has developed a link between stream number 2 and my controller. The next is we need to provide the output, how we are going to control our mass flow in stream number 2, that is by using the valve number 2 in our case here. So you click here on valve number 2 and actuator desired position and click on select. So it has developed our link. One thing I want to highlight here, just keep in mind that this process variable is coming after our valve. That's what makes it a reverse action controller. So we can also just select this and go to the flow sheet and we can flip it for a better representation. Now the next is it is asking what is the range for your process variable. Go to the parameters and this is where we can provide our range. As you can see here, it is a reverse action controller. So let's go to our problem statement and this is my controller number 2. So the range is from 0 to 350 kilogram per hour. For my second controller, it is 0 to 350 kilogram per hour. And the tuning parameters for this controller are, the gain value is 0.5 and initial time for the calculation is 0.45. So let's enter these values here. This is my 0.5 and 0.45. Now we have defined our second controller for our hot water inlet stream, and before you close this window, let's click on the faceplate and we will keep it and we will use it when we run our dynamic simulation, and I can close it now. Now in the next step we need to model our controller, split controller. Just double click this, and now here is the thing that we need to understand. We are looking to control our temperature on the exit of mixer, which is number 3 stream here. It could be any name depending upon what you provided when you are developing the links. So what I want to mention you here, that we are looking the temperature at the exit of the mixer. So my process variable for this stream will be temperature, not the flow rate, just like we were using before. So we are maintaining our temperature of the mixture outlet by regulating our mass flow rate of the cold water stream and the mass flow rate of our hot water stream. So I click on select process variable and I need to click on number 3, and here I will search for the temperature. And we can just select this, and this process variable has been added. Now as you can see that this is my split range controller, so I have 2 options to add the controllers. So let's look on our statement again here. This is the one which I highlighted. We are looking controller 1 for cold water and controller 2 for the hot water stream. So just go here and click on select output target. Once you click on the set output target, you need to find out FIC 100, which is our controller for the cold water, and we want to provide it a set point based on the temperature of my stream number 3. So that is why I selected my SP here and click on select. So what is happening here? We are having the output of the split range controller, which will become a set point for this controller FIC 100, and the similar procedure I will repeat for my FIC 101, which is the controller for hot water inlet. So how you provide the second one? You just go to the second option here, and now it is asking me what is your output for the second one. Same procedure, I click on select output, and for hot water my controller name is FIC 101. Select this, and again I want to keep it set point coming from my split range controller, and just select on this. So now we have provided both of our output target for this. Let's go to the next step where we need to provide the range for process variable. So go to the parameters and go to the configuration, and this is where we need to provide our range values. So let's see what is the information here. So this is my SRG. Let's make it a red color. So my minimum value is 40 and my maximum value is 60 here, and you just enter here 40, and my maximum value is 60 here. Now I have provided my limits of the process variable. The next step is I go to my operation here and provide the tuning parameters. And let's look at the tuning parameters for my split range controller. It is 0.01 and 1 TI value. So it is 0.01 and my TI value is 1 here. Now one thing I want to highlight here, as you can see that our set point at the moment is 52.54, which we can always change when we are running our dynamic simulation. In the next step, we need to develop our strip chart. And before that, let's go here, and this is the important step here. It is asking me what is your setup for the split range. By that it meant to say which controller do you want to act based on the percentage range. So if I go here, this is the thing which I highlighted in the start. If it is 0 to 50% output, it should go to my controller number 1, which is associated with the cold valve. So you come here, and this is 0 to 50%. Click on invert action, and from 50 to 100% you click on invert action. So when the output of my split range is between 0 to 50%, it will go to my FIC 100. When the output of my split range is between 50 to 100, it will go to my valve number 2 controller. And the next is go to the strip chart and click on create for set point, process variable and output. Click on create strip chart, and as you can see there are 3 outputs coming in. I can leave 1 here and click on display. So this is your strip chart for dynamic simulation. So I can close this window, and I can keep this parameter window with me because I need to change my set point here. Now we are ready to move into the dynamic simulation. Click on the dynamic and click on the dynamic mode. The dynamic assistant of Hysys has identified some problems that need our attention. Let's click on yes. Now these are the problems which are identified by the dynamic assistants. There are 2 ways you can solve them. The one is you solve them yourself and the second is you let the Hysys solve them for you. So I'm going to choose and ask Hysys if it can solve these problems. So how we do that? Just click on make changes and Hysys will resolve the issues. However, as you can see that one of the issue Hysys is not able to resolve. How you can fix it? Double click on this, and this is the equal pressure option is active. So just click on OK and click on make changes. Now as you can see that there is a green bar here which says that all changes were made, there are no remaining problems. This means we are good to enter into our dynamic mode. Let's click this and click this again. How do you know that you are in the dynamic simulation? As you can see that these parameters, they are not activated. I click on dynamic mode. Are you sure you want to switch to dynamic mode? I would say yes. And now you can see that these options are activated. So we are ready for our simulation. Couple of things we need to work on. The first thing is we want to make it a cascaded controller. This means to say it will receive its signals as a remote set point. So click on this menu. Now this is manual and this is my cascade. As you can see that when I clicked on cascade, it is creating a small r which stands for remote set point for our flow controller. Similarly, click on this one and cascade. This is again a remote set point for my flow controller. And we also need to change our split range into a auto mode. And before I run the simulation, just go to the integrator, and this acceleration is too high. Let's make it 0.2. And so we can close this window. And now we are ready to start our simulation for this. And click on run here. Now I want to stop it and I want to mention what is happening here. So this is my set point here, 52.54. And this is my process variable. Process variable is already on the temperature on the is already on 52.53, which is difference of 0.01 only, which is not a major difference. So this process variable, this set point is what we provided for number 3, and the temperatures are already the same here. Now depending upon the difference between the set point and your process variable, these are the values or the percentage openings of the valve. So one valve is open 99.33% and the second valve is open as 0.34%. What we can do, let's change this value. If I make it as let's say 60 degree Celsius. Now technically you must understand what I am asking Hysys, either it makes sense or no. So I'm asking our Hysys to give me a temperature of 60 degrees Celsius over here by manipulating the streams of the cold and the hot water. So what will happen? My process variable, currently my temperature at this point is 52.53. So I want Hysys to increase my temperature up to 60 degrees Celsius, right? So what will happen? Hysys will close my cold water stream and it will open my hot water inlet stream so that more hot water can come here and the mixture temperature can be increased up to 60 degrees Celsius. So that's what all this variables means. So let's see how Hysys behaves at this time. So I run the simulation and let me stop this here. Now as you can see that once I run my simulation, Hysys immediately adjusted the valves of openings of my valve number 2 and valve number 1 until I achieve a steady state condition. If I keep let it run for a while, I can see that my set point is equal to my process variables, and this is what we can verify from our split range parameter window as well. Let's change it to 42. I'm going to change my set point at 42, and now you will see that because I'm reducing my temperature, it will automatically close my valve for the hot water inlet. So you enter 42 and hit enter. I will stop it here. Now as you can see that because I have the reduced temperature, it needs to open my cold water valve completely and close my hot water valve completely. So that is what it is happening. It opened my valve for the cold water and it closed my valve for the hot water stream, so that it can reduce my temperature at the outlet of mixture up to the temperature of 42, because currently the stream was at the temperature of 52.53. And I can run the simulation and see when I can achieve the steady state condition. As you can see that this is moving here, and it is this is my process variable. It will go down up to the point of 42 degree Celsius. Because I put an integrator of 0.02, the simulation is slow. I just wanted to explain you what is happening here. So let's try and choose some temperature again. So if I want to make it as a 50 degrees Celsius, let's say, and hit enter, as you can see that Hysys adjusted my parameters again, and it is trying to achieve that set point of 50 degree Celsius. One thing I want to mention before I wrap up this tutorial, this set point range is not the random range. This must be within the range that you already provided. For example, if you go here, go to the parameters and the configuration, this is the range that I have already provided between 40 and 60 degrees Celsius. If you want to provide increase a temperature, let's say you want to provide a set point of 65, you first need to provide a higher value of high limit value here. You need to provide a value which is higher than, let's say, 65 or 65 even. What I meant to say, let's say I want to change my set point to 65. Hysys will not allow me to do so. I enter my 65 and hit enter. As you can see, it is not allowing me to make it 65. Why? Because in my configuration, my maximum range is 60. The same is true for the lower limit. I cannot use 39 here because my range is 40 degrees Celsius. But if I change my range here, let's say I make it as a 70 limit, I can now make a change here for my set point of 65. You don't have to make it 70, even the range is 65, it will work. Now it is accepting my input here because I have changed the limit for my process variable. And as you can see that how Hysys was able to adjust my valves and provided me a temperature, a steady state condition. Now I have reached my steady state condition, and we can see that this time process variable is at 65 and it has achieved the temperature of 65, which was the temperature for my set point at stream number 3, this stream here. So I hope this helps. If you have any questions, please drop me an email, or you can drop by at my office and I will be happy to help you. Thank you.